Sorry, ladies and gentlemen, I lost all the boards. Let's continue. So I was saying, looking at G1, then I can get the absolute value of partial of G1 with respect to X2. And we're able to see that this will just give us an absolute value of minus X3 over 3, then sine X2, X3. So I was saying, found I can even get a bound which is greater than the one that I have there. Okay, by saying sine X2, X3 is less than or equal to 1. So I can say this is also less than or equal to 1 over 3, right? But I can even be more precise by looking at, or by reducing this upper bound by looking at those values that have been given in D. So this can be maximum when I have X2 and X3 equal to -1 and -1. Yeah, X2 equal to X3, which is equal to -1. And this will just be less than or equal to 1 over 3 times sine 1. So if you use your calculator, you'll be able to see that this value will be less than 0.281. Okay, so you do the same thing now to partial of G1 with respect to X3. Okay, so this will be the last partial derivative of G. Looking at those three variables you have, X1, X2, and X3, and you see that this will just be absolute value over minus X2 now over 3, then sine X2, X3. And you see that this again will be less than 0.281. Okay, so we are done with partial derivatives of G1. We need to move on to partial derivatives of G2. So we'll do this with respect to X1, X2, and X3. So the absolute value of this will now be equal to what? Remember, X2 is given by 1 over 9. I mean, G2 is given by 1 over 9, then square root over X1 squared plus sine X3 plus 1.06, then minus 0.1. So you just have to differentiate this. So if we do that, if we find partial derivative of that, yes, sir.
The board is blank, or maybe it's just me.
Is that so?
It's just
others,
It's
you.
just
We
me.
can see.
Oh,
others,
okay.
are you able to see? Are you able to see the board?
Yes, we can.
Yes, we can see.
Okay, I think the problem is with maybe the device you are using. It's just the problem with you. Maybe it's the issue of internet.
Maybe. Let me try to rejoin.
Yeah. So we'll find the partial derivative of that. We are going to have 1 over 9, then 2x1, and then times half. So that will just give us x1 divided by this same expression, x1 squared plus sine x3 plus, so let me rub this part, then plus 1.06. So that's what we are going to remain with. Okay. Now, in this case, I need to make sure that the denominator is small. So I'll pick those values in D, which will make the denominator small. Of course, here, for any value that I pick in there, I'll be getting something which is positive for x1 squared. So since the sign is even, I mean is odd, not even, since sign is even, I'll be able to pick x3 to be equal to -1. So doing that will be able to give me 1 over 9 times the square root over 1. So x1 can be -1 or 1. Then here I'm going to have minus sine 1 plus 1.06. So if we simplify this, it should be able to give us 0.1006. So in all the cases that we have done so far, we are able to see that the value we are getting there is less than 1, right? Even that value is less than 1. Except the other one, which was 0. Okay, but we don't want to have 0. Partial of G1 gave us 0. It gave us 0, but looking at the condition that we have been given, we want a situation where this is less than some number, which is not 0. So let's continue and look at the partial derivative of G2 with respect to X2. Okay, so with respect to X2, what are we going to get? This will just be equal to 0 again. Okay, so let's move on to the next value, partial of G2 with respect to X3. So we see that the only part which has X3 is the square root of sine X3 there. So if I differentiate that, I'm going to have minus cos X3, then divided by the other 1/2, which will be the same as 9 times 2, then times the square root over x1 squared plus sine X3 plus 1.06. That's what I'm going to get. And this will be less than 1/18. Then again, this part, I'll make sure that I pick the part which will give me the smallest value. I need to reduce the denominator in order for me to get a value which is big. So because of that, I will take the absolute value of 1.219. So 1.219 is the value I'm going to get when I use 1 minus sine 1 plus 1.06. So that's what you are going to get there. Okay, if you simplify that, you'll be able to see that it will give you something which is equal to 0.050. So again, make sure that your calculator is in radian mode. So we are done with partial derivatives of G2. We'll move on to partial derivatives of G3. Okay, with respect to X1, we'll do the same. With respect to X1, we are going to get minus X2, then e to power minus X1, X2, everything divided by 20. So that's the value that we're going to get. The other value is a constant, so it will just give us 0. And this will just be less than or equal to 1/20. Then I can pick X2 there to be 1. And then X1, X2, that product in the power of E should be in such a way that it gives me 1. That's the one which will be the maximum. And this will be less than 0.1359. So you'll be able to see that this value will also be equal to partial of G3 with respect to X2. So it will be the same thing. And then partial of G3 with respect to X3 will also be equal to 0, right? So looking at all these, we'll try to compare the values of these partial derivatives and get the one which is the greatest. So we'll be able to see that here I have 0.135. When I move to the next board, I have 0. Of course, 0 will be less than the other, 0.1 something. Then I have 0.1006. Then this and that. So the maximum value will be this value. Okay, so that's what I'm going to get. Because the condition there just says partial of GI with respect to XJ should be less than or equal to M/N. So I know N in this case is just equal to 3, number of variables, which is also equal to the number of equations. So I can say from here, M/N should be equal to the greatest, which is 0.281. so that from here I solve for m. So this will imply my m will be equal to n, which is 3 times 0.281. And if you multiply there, you should be able to get 0.843. Okay, and this value is less than 1. So it agrees with it agrees with that condition which says if partial of each gi with respect to xj is less than or equal to m over n, where m is less than 1, then you'll be able to conclude that G has a unique fixed point. Okay, so we are done with the first part, just showing that capital G has a unique fixed point. Okay, so now we can iterate. According to the question, it says you have to iterate until the xk, the L infinite norm of xk and xk minus 1, if the L infinite norm of this divided by L infinite norm of xk is less than 10 to power negative 5. So now, using fixed point method is very easy. So you just go to those GIs. Okay, so what you are going to do is you'll be substituting G over X naught, okay, that you have been given. And then it should be able to give you, for example, X1. Then, so let me change this and say G1 here. So to find G2, I'll substitute this, and this should be able to give me G21 and so on. So let me do it here. Remember, G1 is given by 1 over 3, then cos x2, x3 plus 1 over 6, right? Now I'm using x to 0 and x3 is 0 here. So you can substitute now values in there. And in this case, you have been given x0 to be equal to 0.1, 0.1, and minus 0.1. So always x0 will be given. So you just have to substitute in there. So I think let me get rid of this so that I evaluate this expression. So this implies x1 will be equal to 1 over 3. Then I'm going to have cos x20 I have 0.1 and x30 is negative 0.1. So I'll multiply this and then plus 1 over 6. So if you use your calculator there, you should be able to get this value. So verify that the answer you're going to get will be 0.4999, then 8333. Okay, so that's the value you're going to get. And then we'll do the same thing to get x21. So x21 will be equal to G to x0. And this will be equal to G2 is given by 1 over 9, then square root over x1 squared. So I'll say 0.1 squared, then plus sine x3 is negative 0.1. Okay, then plus 1.06. So if you use your calculator, this value should be equal to 0.00. Of course, there's minus 1 here, sorry, minus 0.1. So if you evaluate that, it should be able to give you 0.00944115. Okay. Of course, in the notes, I made a mistake here. There's a typo here. I've put a plus. plus 0.1, but it's supposed to be plus negative 0.1 because x3 is equal to negative 0.1. Okay, and then we'll do the same thing to get x31. So x31 will just be equal to g3 x0. Okay, so this will just be equal to g3 is given by negative 1 over 20, then e minus x1 x2. So this will be x1 of 0 and x2 of 0. I'm just displaying what is on top there, so I'm unable to write something on there. I mean, something as a power of x1 and x2. So just know that those values are gotten from x0, and then here I have minus 10 pi minus 3 over 60. So we'll substitute the values that we have been given, and this will just be equal to minus 1 over 20, then e to power minus x1 is 0.1, then x2 is 0.1, then minus 10 pi minus 3 over 60. So you can use your calculator again and see that this will just give you minus 0.53, no, 52310127, right? So after doing this, now I can write my x1. So x1 will just be equal to the first value I got, which is 0.49998333. Then the next value I got is 0.009444115, and the last value negative 0.52310.127. So that's the first value I'm going to get when I do the first iteration, right? Now, in order for me, whether this is where I need to stop, I need to use the stopping criterion that I've been given. So I need to find the L infinite norm of x1 minus x0. Then this divided by the L infinite norm of x1. Okay, so you'll be able to see that the L infinite norm you have in the numerator will just be equal to what? You have 0.1, so the maximum will come from that value. When I say minus 0.52310127 minus 0.1, so it will be this value plus 0.1. Okay, so it will give us 0.42 0.42310127, then divided by the L infinite norm of x1 will just be that same value, 0.52310127, and this value you'll be able to see that it will be greater than 10 to the power negative 5. So it means I need to do more iterations, right? So I need to move on to the second iteration. So I'll find x12 now, which will be equal to g1 x0, and this will be equal to g1, as you know, it's 1 over 3, then cos, someone says now black, x2, x3. So now I'm picking x2 and x3 from x1, capital X1, then plus 1 over 6. The one who is saying now black, where is the problem? Hello? You can go on and ask your question. Okay. Says you can go on. Okay. Okay then. Thank you. So I'll be able to use this to find my x12. I can do the same to find x2. So now I'll be substituting in G2 values of G1. Sorry, I'm using 0 here instead of 1. Here, the values I'm using are for X, capital X1. Yeah, I'll be using this to find X2. So I think it's something that you can do. And this will just be equal to 1/9 square root over X11 now squared, then plus sine X31, then plus 1.06, then minus 0.1. So we should be able to do that. After finding this, we need to find the L infinite norm of X2 minus X1 divided by L infinite norm over X2. Okay, we'll be able to see that again, this value will be greater than 10 to the power -5. So we'll continue in this way, and we'll be able to see that the value which will satisfy this stopping criterion will be for K equal to 5. So other values for the other iterations, like the second iteration, third, fourth, and fifth, are given in the table. You have one table in your notes, so you can refer to that. So that's how we use the fixed point method. It is very simple. If you have been given the initial approximation, all you need to do is to substitute values of X naught, and then you should be able to find the answer. Okay, so there's a question from Kanika.
Yes, sir. I've noticed that the answers that we have obtained after our first iteration, we are writing so many decimal places. Then in one of our previous examples we looked at in the previous lecture, the question would specify that, okay, round off to maybe 4 decimal places. So what's your recommendation on this one? Like at times when you are solving, you have a lot of work to do, and obviously dealing with a lot of decimal places would be tedious.
Yeah,
so where what are we supposed to do?
You can be given a condition in the question. Maybe it can say to 4 decimal places or 3-digit rounding off. So you'll be able to use that. Here, as an example, I'm just giving you values as I'm getting them on my calculator. So, of course, you can be given another condition to say you round it off to 4 decimal places or 3-digit rounding off, something like that. So that shouldn't be a problem, sir. You'll just be given conditions in the question.
All right, sir.
Okay, you're welcome. So that's all about the fixed point method for nonlinear systems of equations. So you just need to make sure that you iterate according to the conditions given in the question. Okay, so we can move on to the next method, the last method we're going to consider. Mr. Shilengwe.
So I think, can't we end here today? This is already a lot to grasp. Personally, I won't be able to understand beyond this.
Christopher. What's so difficult here? You're just substituting values. I was thinking we can look at Newton's method. It's not that long. We still have 1 hour. Can't we finish this so that next week we start looking at a new chapter?
It's fine. Moreover, sir.
On Monday.
Hello?
You want us to finish on Monday?
Hello?
Yes.
Okay.
Hello, sir.
Yes, Mr. Mwemba, I can get you.
Yes, for me, I have a different view. You can go on, and if someone is not able to grasp, they can grasp when they watch the tutorial, since you're doing a recording. And if they have challenges, maybe next time when we meet, maybe they can ask a question. Because we are looking at time, we are already behind the schedule, so it's better to try to compress a bit. I think for me, I would suggest that you complete.
Okay, I get you, sir. And I'm of the same view as well, but I can see a lot of people are saying, no, let's end here. I've seen another message from Boniface and another message from, okay. Okay, let's do this. Let's end here then. So we'll be able to look at the other method on Monday. Let me allow people to go through this method that we have considered today. It is a very simple method, as you can see, ladies and gentlemen. All you need to do is to iterate according to the conditions given in the question. And you make, you find values for functions gi from the function fi, and then you should be able to do that. Okay, then let's end here, ladies and gentlemen. Have a nice weekend. We'll meet on Monday at 16 hours. So someone is talking about a tutorial session. I don't know how we can do it here because a tutorial is your show. I would like you to solve those questions. Now using this method, I don't know if you'll be able to solve questions nicely. I know some of you are using phones. It will be difficult to write on the board the same way I'm writing. So maybe we can have those tutorial sessions when you open, if at all you're going to open. Yeah, so let's end here, ladies and gentlemen. We'll continue on Monday. You're welcome. So I'll post the videos. I've recorded the 2 videos that we just had this afternoon, and then I'll post them on Moodle before 18 hours. Okay, enjoy your weekend. See you on Monday.
Thank you, sir.
Sir,
Yes, sir.
how about solutions, sir, to the tutorial sheet? Giving us solutions just.
Sir, that's a lot of work. I'll be encouraging laziness. Just solve them. Maybe some people will start memorizing those answers. I think it's something that you can easily do. Just go through them, and then if you happen to have a question, maybe at the end of a lecture like this, you can ask your question and say, okay, I was trying to solve this question, and then I was stuck here. How do I proceed from here, and things like that, and then I'll be able to help you.
Or maybe
Okay,
the other way is,
yeah, because
sorry?
it will mean after solving those questions, I start typing them, plotting them. No, I think, ladies and gentlemen, just solve them, and then when you happen to have a question, you can let me know, and then we can discuss.
Sorry, sir. Hello.
Yes, sir. Yes,
Yeah,
I
maybe
can get
another way
you.
would be if I told they have those those questions that we sent have got solutions. You can maybe give us the final answers so that as we try them, we're able to check whether we've done the right thing. Maybe just the final answer.
Or just the final answer.
Yeah, just the
Okay,
final answer.
I'll try to do that. Okay, then, no
Okay.
problem. I'll try to do that.
Okay, sir. Okay.
Okay. Thank you so much. Enjoy the rest of your day.
Thank you, sir.